Hi everyone, I'm Atamil. Next I will demonstrate to you the shader graph we developed ourselves in the Smart PBR engine. I will close our tool first. Select the demo object in the scene, then show everyone the current effect briefly. Next we will start explaining the shader part. The first part of the shader is the base color part. In the options here for base color, we have designed it so you can adjust your UV tiling value, then your UV up and down offset, and your UV rotation. Next is the ORM part. The ORM part is designed so you can adjust material roughness AR, its corresponding black and white contrast adjustment. Here I will switch to the rendered ABUGA, so everyone can clearly see how we are adjusting it. Here I use the smooth method, which is also the roughness channel to adjust. We can see the currently presented roughness is XTRY value is 1. So if my X value goes in a negative direction, it will appear darker. This adjustment method allows artists to more intuitively adjust the black and white contrast effect value you want. This adjustment method is relatively the same principle as Photoshop and Substance Painter is the same principle. This will be convenient for artists to reproduce their work. If I set the X value to 1 and Y to 0, the black and white contrast will be reversed. That's the explanation of one ORM channel. I'll switch back to normal. Let's continue looking. Next is the normal part. The normal part is relatively simple. It just adjusts its normal intensity. In the normal part we also designed a detail normal option. Here I will use a wood floor normal as an example, so everyone can see more clearly. After pasting the wood floor normal texture, you will see nothing. That's because the current intensity is 0. We adjust the intensity to be stronger, so everyone can see it clearly. Here you can also adjust its UV. I will adjust the intensity to 1.5. This way, we can create many interesting normal overlay effects to make your material richer. Here I adjust the normal to 0 and delete the normal. Pay special attention here, because by default, it directly assigns a normal color. So if your intensity is 1, it will still present an overlapping normal state. So it must be 0. Next is the height map displacement map mode. In the displacement map mode, it involves the following functions in total. The areas are currently boxed in yellow. All belong to the corresponding adjustment functions of the displacement map. We will explain them in detail one by one. In HDRP mode, we designed 2 modes. The first mode is the parallax occlusion mapping PLM mode. The second is the tessellation mode for subdivision bump. For this demo, I will first use the tessellation mode to explain to everyone. Later we will switch to the POM mode of parallax occlusion mapping for everyone to see. In tessellation mode, we can look at the tessellation settings here. I set the maximum displacement mode to 64. Now please refer to your personal computer equipment to adjust this value. The graphics card I use is a 4070Ti, so adjusting it to 64 is currently within an acceptable range for me. If your graphics card has lower requirements, it's recommended to adjust it lower. Next is the bump contrast adjustment of your displacement map. And here is tessellation. Most important adjustment thing, which is mesh subdivision. We can switch to the wireframe mode to observe. Again, the data adjustment here is based on your personal computer equipment system. I currently adjust the subdivision to 20. The mesh density makes me feel the current effect is acceptable. If I adjust it to 0, you can see this mesh will completely flatten out. This is a mode unique to Unity's HDRP. You will slowly adjust the mesh subdivision for everyone to observe. Okay, I'll adjust it back to 20. And switch back. Next, these two corresponding adjustment values are the black and white contrast adjustment values of your height map. These adjustment values allow you to adjust the height of the bumps you want for your stone. Go on, adjust the degree of the bump at the top to do a detail adjustment. For example, if you want it to feel more swollen or less swollen. Next is when your stone bumps up, the degree of your edges. If you want to make it blurred, area, or sharper, you can make a detail adjustment on the crevices here. That's the part of this adjustment block I designed. Next, this point option allows you to adjust its explosive stretching. This function is mainly to adjust the degree of your scene. Of course, if you want the edges of your model to be more perfectly beautiful, it's recommended that your model needs to be beveled, and your normals must present a soft edge state. Then your displacement map effect will be more beautiful. Next, let's look at the POM mode. The current effect of this material is adjusted using the POM mode. We can move and take a look. Okay, when switching to the POM mode, we need to pay a little attention. In the POM mode, the depth displacement here must be turned off first, lest your lighting and shadows present a very strange state. Then you can start adjusting. In your POM mode, I set its depth value here to 0.65 as the most moderate. This value depends on your vision. You feel your various angles don't look too abrupt. Adjust this according to personal needs. I'll use 0.65 here for a test. Next is the tiling size of your displacement map inside. It is recommended that this tiling size matches as closely as possible with your set UVs. Tiling to remain consistent. It is recommended that this effect will be better. So the current adjustment value is still acceptable within a permissible range. Next is the most important performance optimization part. The LOD camera distance for performance optimization represents your Y value, which means if my camera lens is this sphere, my sphere in the position distance of my POM maps mesh to means to meters. This unit is in meters, so my distance is capped at 2 meters. The LOD state it presents is that it has no POM effect. Here we adjust the LOD value to 0.9 to keep it default. That is, when I exceed this distance, I default to turning off the LOD, which is turning off the POM. If I keep getting closer in distance, It will slowly decrease in sequence, decreasing to 0. At 0, you can see the PLM effect is the most detailed. Next is the detail part. This is your pushed out depth adjustment value. You might adjust it to 20. Next is the degree of detail of your pushed out depth. If I set it to 0, here you can see very obviously, there's a change here, it becomes 0 steps. If I set it to 4 steps, the higher the number of steps, the finer the details raised here will be. If I set the X value to 1 and Y to 0, the black and white contrast will be reversed. That's the introduction to the PLM and tessellation modes under HDRP mode. Next is the emissive map option. You might paste a black and white map to assume it is an emissive map. Then, we adjust the intensity a bit higher, and adjust the color to a brighter color. We can see. Here you can see our emissive map. Next is the explanation of the detail texture part. In the detail texture part, we'll first use a conspicuous texture. For an explanation, you might choose the Woods Era 65 material. I first paste the texture map of the corresponding channel. Connect normal here, connect my ORM here. You must pay attention here. Our current detail texture part is designed to only take ORM maps. The reason for doing this is to save your shader as resource performance. Next, I'll leave the mass map part empty for now. Then start explaining the details below. If your texture map is designed so RGB channels have different textures, for each channel, you can use UV mapping. Here we can choose to switch to the corresponding UV mapping part. The corresponding channel name is UV1 equals R, UV2 equals James, UV3 is B. The RGB channel is right here. Then you can also adjust here your detail texture styling and offset and rotation values. We currently don't see a texture effect because the current blend degree is 0. One thing to note here is we use detail texture as an embellishment effect, so it doesn't let you adjust finer black and white contrast. So its OR and value must be adjusted well before pasting. Here we start to do a blend effect. We set the color map blend value to 1. You can see the whole color and the whole ORM are brought in. We adjust the ORM value slightly, so it's not so strong. Next, we try to adjust the normal part a little bit more. Then we adjust the UV tiling part, move it a bit and rotate it a bit, and we can get more richly detailed textures. If you only want this texture effect to appear on a certain part, then we can use the mask map option to control your texture. You might select a material to paste. We can see the current effect of the pasted material. It shows that this part has been drawn on, so it appears here. Here we can also adjust the blend degree again. This way, your stone texture will present more texture. That's the introduction to the shader we developed. If you have any opinions about my shader, or thoughts or want to add some functions, feel free to add to me, and I will consider whether to add them.
Thank you for your purchase and your support. I am the creator, Atmiel.